Alrighty guys, so in today's lecture we're going to be learning about something called dimensional analysis. But before we do that, I do want to let you guys know that you guys will need a calculator for today, so just make sure you have a calculator handy. And you will need this conversion chart. I have it attached on our assignment on Canvas, so make sure you guys download it, either have it printed out, copied down, or somewhere handy on your phone or something like that, because we will be referring back to it. Now, before we get started, let's do a little bit of review of our algebra skills. So here we have two fractions, and it looks like we're multiplying them together. Now, I do want to let you know you cannot cross multiply. You cannot cross multiply. And the reason why is because there is no equal sign. If these two things were equal to each other, you can cross multiply, but the equal sign is not between them. We're trying to find out what they form. And so in this situation, we're just going to have to multiply. Now, one thing I want to let you guys know is if you have something on the top of a fraction, and if you have the same thing on the bottom of the fraction, you can cancel those out. So here we have 3x and we on the top, and we have an x on the bottom, which means we can cancel out the x's. And so before we even get started, we can just get rid of the x's, and that's going to give us 3 over 5 times 4y, and we canceled out the x, so it's just going to be 1. And so solving this becomes very easy. All we need to do is multiply the top. So 3 times 4y, 3 times 4 is 12, and we keep the y. And then on the bottom, we do 5 times 1, which is 5. And so this is going to be our answer, 12y over 5. Okay, this is the simplest that we can get it. Alright, if we look at the one on the bottom, you're going to notice that we have a whole number, 5x. Now, we learned last time that if we have a whole number, if we want to write it as a fraction, it's just over 1. So 5x over 1. Now there's an x on the top and an x on the bottom, so we can cancel out the x's. We can cancel out these x's. Now if you notice, there are also y's. Now there's a y on the top and a y on the bottom, so we can cancel those out. Which means now we have 5 over 1, because we got rid of the x, times 8 over 0.7, since we got rid of the y and the x, times, we have 5a, so the a did not cancel out, so we got to keep that, 5a over 3.17. Okay, so we can just solve this out by multiplying. So we can go on our calculator, and we just need to multiply the tops and multiply the bottoms. So on the top, we have 5 times 8 times 5. So we have 200 on the top, but remember it's 200a because we still have the a, so we have 200a. And on the bottom, we just multiply what we have on the bottom. So on the bottom, we have 1 times 0.7 times 3.17, and that's going to give us 2.219. And so we're just going to get 2.219, and we'll just leave it like that. If you want to simplify it further, you're going to have to divide the top by the bottom. So what we can do here is we can do 200 divided by 2.219, and then that'll give us 90.13. So we'll get 90.13, and I'm going to round up to 61a. So this will be our final answer. I guess you could simplify this one up here as well. We could have done 12 divided by, we could have done 12 divided by 5, and that'll give us 2.4. So the final answer for the first one could also be 2.4y. Okay, so that's basically how you solve it out. Very simple. You just need the point is, I just want you guys to cancel out the tops, whatever's on the top with whatever's on the bottom. So before we talk about the dimensional analysis, I want to talk about something called units of measurement. So a unit of measurement, and you guys already know what this is, it's basically how we measure stuff. So there's 3 different main types that we'll be talking about. We have mass, length, and volume. Mass is how much of something there is. So we can do pounds, right? So if I have something like 8 pounds, that means pounds is going to be my unit of measurement. If I have something like 7 grams or like 12 kilograms or 130 milligrams, that means milligrams is going to be my unit of measurement. So basically, how you describe your numbers is what we call a unit of measurement. And I just like to call it units just to be quick, but that's what it is. We also have length, how much distance something extends, how long something is. So if we have like, I don't know, 12 inches, inches would be your unit of measurement, or meters, centimeters, so on and so forth. And then we have volume, how much space something takes up. So we have liters, milliliters, gallons. So if I have 1 gallons, that means gallons is going to be my unit of measurement. Now the reason why we're talking about this is because in chemistry we measure a lot of things and we do a lot of math, but you can never give me just a number. So if you write in chemistry that the answer is, I don't know, 3.4, that's incorrect because this is your number, okay? But this number doesn't mean anything unless you describe it with a unit of measurement. So if you say 3.4, what does that mean? 3.4 pounds? 3.4 grams? 3.4 feet? Like the number doesn't mean anything by itself. So you always need to have a number and you need to have your units. Okay, so 3.4 pounds would be fine. So LBS. Okay, or 3.4 feet, 3.4 miles. You have to describe your number, okay? So just remember, going forward, if you just write the number, your answer will be incorrect. You have to give me the units as well. So make sure you guys keep that in mind. Alright, so now we can talk about dimensional analysis. Now before we can do dimensional analysis, we have to learn how to write something called conversion factors or ratios. It's very simple. When you see that one thing is equal to another thing, all you need to do is you just need to turn it into a fraction. So here we have 2.54 centimeters equals 1 inch. If I want to write a conversion factor or if I want to write a ratio, all you need to do is write, hey, 2.54 centimeters over 1 inch. Or you can do 1 inch over 2.54 centimeters. And either one of these will be your ratio. Okay? It's that simple. If you see something equal to another thing, you can write it as a fraction, and that's your ratio. So, another example, we have 1 kilogram equals 2.2 pounds. See if you can pause the video and write the ratios on your own. Okay, you should have written 1 kg over 2.2 pounds, or you could have written 2.2 pounds over 1 kg. Okay, so here we know that they're equal to each other because there is an equal sign, right? That is how we know these two things are equal to each other. Another way people like to write how two things are equal to each other is this term per. Okay, so 45 miles per hour. What this means is 45 miles equals per hour is 1 hour. So that word per basically means equals 1 and whatever comes behind it. So per hour means equals 1 hour. So if I wanted to write a ratio for this, it would be 45 miles over 1 hour. Okay. I do want to make a quick note. Miles is always abbreviated as MI. If you write M means meters. Okay, so just make sure you guys keep that in mind. Miles is MI. If you write 45 M, that means meters, and that's very, very slow. 45 meters in 1 hour, whereas 45 miles per hour is pretty fast. If you're running it, it's okay in a car. Okay, another way you can write this is 1 hour over 45 miles. Okay? And then lastly, you can use the word is to describe it. 0.5 hours is equal to 1800 seconds. And you can write the ratios as 0.5 hours over 1800 seconds or 1800 seconds over 0.5 hours. Okay? So that's how you can write some ratios. There are different ways to describe it. Again, you'll see it as equals, you'll see it as per, and you'll see it as is. But when you see two things that are equal to one another, that means you can write them as a fraction, as a ratio. Okay? Alright, now this is important for dimensional analysis because we are going to be doing this basically till the end of the year. This is what chemistry basically is. So this is the formula that you have to have written down. Make sure you have this written down, and I think eventually you will memorize it. Is if when you're looking for a unit and you're trying to change it into another one, you want to write what you start with. This is your starting unit, your given unit, and then you want to end up with the desired unit. This is basically what you're looking for. Okay, and the way that you do it is you do it with this kind of fraction, a ratio. We talked about this a second ago. Okay, you start with your given unit, you use a ratio, and then you use the ratio to cancel out what you started with so that you only have what you're looking for. Now I know that sounds a little bit complex, but it's very easy. Let's do it in a problem. Okay, so the problem is asking us to convert 155 pounds into kilograms. Now the first thing you want to start off is let's figure out what you're given. So what are you given? Okay, easy way to think of that is just look for the number. We have 155, so we are given 155 pounds, and then we want to find out what is desired. Okay, what we're looking for. What's desired? We desire to turn this into kilograms. Okay, so let's use this formula. So we're going to write our given unit, what we start off with. So I'm going to write 155 pounds. And then we're going to set up a fraction. So set up a fraction. And then it looks like we're going to put what we started off with on the bottom. So we started off with pounds. So I'm going to put pound on the bottom. And we're looking for kilograms. So I'm going to put kilograms on top. So what that means is here we need to have a ratio where we have kilograms equals to pounds, or the other way around, pounds equals kilograms. So what we're going to do now is we're going to go to this chart right here, and we're going to look for something where pounds is equal to kilograms. Okay, so take a second to find it. We have it right here. 1 kilogram equals 2.2 pounds. Okay, 1 kilogram equals 2.2 pounds. So what we're going to do is we're going to take this and we're going to turn it into a ratio. We said earlier if we have two things equal to one another, we can just make a fraction out of it. So it looks like 1 kilogram, so we're going to put 1 next to kilogram, is equal to 2.2 pounds. So 2.2 is next to pounds, so we're going to put 2.2 on the bottom. Alright, and so if you guys notice, we have pounds, pounds, and so we have pounds on top and bottom. And we learned earlier, if you have something on the top and bottom of a fraction, you can cancel those out. And the only thing we have left is kilograms, which is what we're looking for. So what we're going to do is we're going to multiply the tops, because this is basically over 1. 155 times 1 is going to be 155. And we have kilograms on top, so we're going to keep the kilograms, divided by 1 times 2.2, so we have 2.2 on the bottom, and we got rid of pounds, so we can keep it. So what that means is we can just do top divided by bottom. So what we're going to do, 155 divided by 2.2. And so your final answer is going to be this right here. So that means that 155 pounds is going to equal 70.45, and I'm going to round up 55 kilograms. Okay? Alrighty, so that's how you do dimensional analysis in order to convert one unit of measurement to another. Now, I do want to mention, you have to show me these fractions, this part right here, in order to get credit going forward. I know it's kind of a pain in the butt, and some of you guys know already, hey, I can just divide it. But eventually, as we go further into chemistry, you will need to set up these fractions, or you will get all your answers wrong because it gets very confusing. I know it's kind of a pain right now with these one fraction problems, but eventually we're going to have 2, 3, 4 fractions at a time, and so it is very helpful to use this method. So again, if you do not have this part right here, even if you have the correct answer, you will not get points for your assignment. So just make sure you guys have the fractions and your final answer. Alrighty guys, so let's try another problem. So in this problem, we need to figure out again, what are we given? So what is our starting number? And then we also need to figure out what are we looking for. What is our desired unit? Okay, so let's start off with our given. If we read the question, it says convert 30 feet into meters using dimensional analysis. So let's figure out what our starting number is. Our starting number is obviously 30, right? So we're going to write 30, and it's 30 feet. Okay, so we have 30 feet, and we need to turn this into meters. So we're looking for meters. Okay, so what we're going to do is we're going to start by starting off our equation. So we're going to write 30 feet, and if you guys remember, we're going to set up a fraction, and on the top of the fraction we're going to put what we're looking for. So on the top we're going to put what we're looking for. Okay, we're looking for meters, so we're going to put meters on the top, and on the bottom we're going to put the given unit. Okay, the starting unit is feet, so we're going to write feet. So we're going to have to figure out a fraction where we have meters or we have to figure out a fraction where we have meters and feet together. So if we go here, we can look through our conversion table, and you're going to see, hey, there's feet right here, but it looks like it's equal to inches. And we have meters right here, but it looks like it's equal to centimeters. I don't see anything where it's feet equals meters. I can't find it on this chart. So what that means is first we're going to have to turn feet into inches. So we're going to have to do feet, and we're going to turn it into inches. And once you get inches, you're going to turn that into centimeters. And then you're going to turn centimeters into meters. So this is why I said we're going to be using these fractions, because it gets more complicated as we go forward. And so it'll actually help you guys out if we set up a bunch of these fractions. So what we're going to do is, instead of putting meters on top, we're going to use the fraction that we have right here. So let me clear this out so it's easier to see. We're going to use this first equation, this first equal sign. 1 foot equals 12 inches. So what we're going to do is we're going to put feet on the bottom, because that's what we want to get rid of. And then so we're going to use this. 1 foot equals 12 inches. Okay, we're going to put feet on the bottom, and it looks like the number next to feet is 1. So we're going to put 1 foot on the bottom, and then on the top we're going to put 12 inches. And the reason why we do that is so that these feet can cancel out. Okay, and so we just have inches now. Next thing we're going to do is we're going to use the second one right here. It looks like we have 1 inch equals 2.54 centimeters. So we're going to set up another fraction times. And we have inches up here, so I want to get rid of inches, because remember, we're still looking for meters. We're going to put inch on the bottom, and it looks like the number next to inches is 1 inch. So we're going to put 1 inch, and 1 inch is equal to 2.54 centimeters. So we're going to put 2.54 centimeters on the top. And then the inches are going to cancel out. Okay? Alright, we're not done because we have centimeters, but we want to find meters. So what we're going to do now is we're going to set up a third fraction. And here we're going to use this third equation. We have 1 meter equals 100 centimeters. Okay, so on the bottom we're going to put 100 centimeters, because we have centimeters here and we want to get rid of the centimeters, and that's equal to 1 meter, so we're going to keep that. So centimeters cancels out, and if you notice, the only thing we have left now is meters. There's no other units, it's just numbers, so we can finally solve the equation. So what we're going to do is we are going to punch that into our calculator. So first thing you want to do is you want to multiply everything on top. So it looks like the numbers we have on top are 30 times 12 times 2.54 times 1. And so that's going to give you 914.4. So on the top we're going to have 914.4 meters. Okay, don't forget that M. Okay, over, and on the bottom we have, remember, this is a 1, so we have 1 times 1 times 1 times 100. So we're going to have 100 on the bottom. And there's no feet, inches, or centimeters because they all got canceled out. And so what we're going to do is we're going to take this fraction and we're just going to simplify it. So 914.4 divided by 100. And so our final answer is going to be, 9.144 meters, because we have the m still. Okay, so 30 feet is equal to 9.144 meters. Okay, and again, in order to get full credit, you have to have all of your fractions set up and make sure you're showing me how you're getting your answers. You can't just give me 9.144 meters. Alrighty guys, so we're going to go over the last problem for today's lecture. And so if you feel confident, I encourage you guys to try it on your own. But if not, I'm going to take it step by step. So here, again, we're going to start off by figuring out what we're given, and we're going to figure out what we end with, what we should end with. So it says convert 10 kilograms into ounces. That means we're going to start with 10 kilograms, and we're going to end up with ounces. Okay, so that means we're going to go to our chart right here and look for kilograms, and we're going to look for ounces. So let's look for kilograms first. I have kilograms here, and I have kilograms here. So here we have the option to turn kilograms into pounds, or we can turn kilograms into ounces. So our options are, you could turn kilograms into pounds, and we can turn kilograms into ounces. It doesn't look like we have anything that could turn kilograms directly to ounces, so we're going to assume that we're going to have to do multiple fractions. Okay, now we're going to look for ounces. So ounces, we have ounces equal to pounds. So we notice here we can turn kilograms into pounds, and then we can turn pounds into ounces. So we're going to be using these two equations right here for our ratios. Okay, so let's do that. We're going to turn kilograms into pounds first. So we're going to start with our number, 10 kilograms, and we're going to put what we start with on the bottom. We're going to put kilograms on the bottom, and we want to turn that into ounces. That's going to be step 1. So we're going to put pounds on the top, because our step 1 is turning kilograms into pounds. That is our first fraction. Okay, so here we're going to be using this formula right here. We have 1 kilogram equals 2.2 pounds. So that means we're going to put 1 on the bottom because it's 1 kilogram, and we're going to put 2.2 pounds on the top. Okay, we do that so that the kilograms can cancel out, and now we have pounds. So now we're going to turn pounds into ounces, and that's going to be step 2. That's going to be our second fraction, and we're done after that. So we're going to set up one more fraction, and it looks like here we have 1 pound equals 16 ounces. So that's what we're going to put into this fraction. So we have pounds on the top, so we're going to put pounds on the bottom so they can cancel out. And then we're going to put ounces on the top because that's what we're looking for. So we have 1 pound equals 16 ounces. So we're going to put 16 on the top so that the ounces can stay with 16, and 1 on the bottom so 1 can stay with pounds. And then the pounds will cancel out. Okay, and now all we're left with is ounces. So now we can solve this out. So what we're going to do is go to our calculator and just multiply everything on the top and then divide by everything on the bottom. So we have 10 times 2.2 times 16, and that should give us 352, and we need to divide that by everything on the bottom, but we just have ones on the bottom, so we don't need to divide that. So our answer is going to be 352 ounces, because that is what we have left over. Alrighty guys, so that's dimensional analysis. Again, in order to get credit for your problems, you're going to have to give me this entire thing right here. You have to give me the fractions and the answer. Everything inside the black box is what I'm going to be requiring for you guys to get full credit. So just make sure you guys include that in your assignment. Let me know if you guys have any questions. I'll be on the Zoom call, and we'll see you guys next time.